So this video is about how do I get a good research question. Now it was asked specifically for an IB chemistry internal assessment, but it's just as good for any science fair project, for your IB extended essays or biology, physics and chemistry internal assessments, or any other sort of science experiment that you're trying to do. Have a watch of this video. It's all about getting in to see what's been done before and modifying that to help extend and enter into the academic conversation. So here we have the question from, it says here, I have somewhat an idea of what I like to do involving IA chemistry. Now that's very important. If you're unsure of how to go about things, I use the Google Science Fair. If you go to my website, you'll see that there's a link there on how to get your interest. So that's a good thing. And this thing is very similar to an example exemplar. So you've got to be careful that you're doing something that's unique, which won't be hard. So have a look here. Carbonic acid affects seashells, and he wants to know how I go about it and how I make something that is important and I can elaborate on. So I've replied to him basically saying you've got to be able to get into the research and you've got to work out what's been done and then extend that or alter that. And so you're basically extending the scientific knowledge of the world. Now he's gone into a little bit more detail here, and he's emailed me back here saying I need a bit more clarification. And so he's looked at here, he's gone for the effects of acidity on shells. So he's getting a little bit more specific. It still is a little bit too broad. And secondly, what can I do for this? I know that they're made up of 94%. I could put them in various amounts of acid. So this student knows it's a basic acid metal carbonate reaction. So you can work out, you can use some carbonic acid. You can put the calcium carbonate stuff into a beaker, and you could measure the amount of carbon dioxide gas coming off of that. That might not be enough. You're probably going to measure it with a balance to some sort of gravimetric method. And so this is how you go about solving all your problems. So the key is getting into your scientific research. So how do you do that? Well, you need to find out what the scientific research is. So if you go under Google Scholar, and his question was the effects of acidity on shells. So just go have a look and see what's on Google Scholar. And already you come up with some fairly good research here. So if you just basically grab research to the point where you feel like you're getting a common theme or you're getting some repetition, that's how you know that you've finished your research. Now I'm just going to click on this one because it looks like a range of pH. And here you need to look up that journal article. But if I just have a look here, what have we got here? We've got a species of shell, we've got a range of pH, and we've got a mortality rate. Alright, so and you've got different temperatures here, and you've got different sizes. So this is probably enough to cover the entire class. So you could try a repetition of this in a different situation. So you could go down and maybe get some different species. So I've got some shells here that I've bought from a shop down at the beach. And so you could get thousands of different species and see whether that actually applies for a different species. You can also test and see whether the temperature affects it for that particular species, or you could change some other factor that's included in here. You could also adapt their method and slightly change their method. And so what you've got here is really the potential for perhaps even tens of thousands of different IAs, and all you're doing here is you're extending the knowledge. You're not repeating anything, you're improving the knowledge. You're showing how it works with thousands of different species at different temperatures, at different sizes, different size shells. The list goes on and on and on, and it really is quite interesting, and it really is helping. It really is what science is all about. It's about getting new information, building and learning from each other. It's about collaboration. So I hope you enjoyed this video. It's a question that every single science student seems to ask, no matter how good or how bad they are at chemistry. Please pass this on, and hopefully everyone will start doing really, really good science research and extend the scientific endeavour.